Good morning, everybody. Yeah, new week, and we are in the general discussion that we go further in our macroeconomic model. From our introductory course, we had that dependence between commodity markets and money markets via the IS and the LM curve, and now we are developing further this model by adding the international dependencies, and this we are doing via the exchange of goods and services and also via the capital flows between a country and abroad. And this is then done like the national account system for the intern economic relationships via the balance of payment. This also has to be balanced. So on the one side, all goods and services we are exchanging, and on the other side, all the capital flows, and these two have to equate. And this equation then will give us the so-called ZZ curve. And this, of course, will then depend on the prices of the goods we are exchanging internationally. Well, and this, of course, this price relationship is then done also by price relationship is the exchange rate, and of course especially the capital flows also depend on the different interest rates which are possible in our country and abroad. And of course, if abroad the interest rates are higher, then it is more attractive for us to buy assets abroad. So we have then two new variables, the exchange rate and the, so to speak, global interest rate, or in general the interest rate abroad. Okay, and this part then we add for once also, of course, within the IS curve. And remember the national account system. There we said that from the dependiture view, that total income in a country is just private consumption, general investment, government expenditure, and now also the net exports. So this is then X minus M roughly, and this net exports then depend, of course, on the income at home. Y minus sign here in the dependence, of course. If we are richer, then we are starting to buy more goods abroad. So we are importing more goods, and therefore we have the minus dependent. And the other way around, if the country abroad is richer, then they are buying more goods from our country, and therefore our exports would increase, and thus we have an positive dependence. Well, and then the dependence on the interest rate last week we discussed widely, because there, of course, the dependence, if it's plus or minus, that is not clear. For this, we have to make the assumption that the so-called Marshall-Lerner condition holds, And yeah, qualitatively, the argumentation is the same when you are talking about revenue of a company and what is the impact if you are increasing your prices of the goods you are selling by your company. What impact does this have on the revenue? Because if you are increasing the prices of your good you are selling, then of course you are hoping that your revenue will increase. But your revenue is price times quantity. And then if you increase your price, this means that prices go up, but in general, of course, the demand is a negative function depending on prices, so demand will decrease. And then the result depends on the elasticity. If you're increasing prices by 1%, are your quantity decrease more than 1% or less than 1%? And this just depends on the demand elasticity. Is this in absolute values less or larger than 1? And the same we have to do for these net exports, depending on the exchange rate, because the exchange rate is roughly spoken just the relation between export prices and import prices. And for this, we have made these long derivation that we then came to the conclusion when net exports we are defining here, including the exchange rate 1 over E. And this is important. I wrote it down here that we used the so-called indirect quotation. And we usually, if we take the view of your home country, you usually take the indirect quotation. So in our times, we just say that I think today, or let's have a look at it. What is it today? Exchange rate, I think 1.10 or something like this. Euro, US dollar 1.07. So indirect quotation means we are judging the price of a unit domestic currency in terms of the foreign currency. So 1 euro, for 1 euro you have to exchange 1.07 US dollars. But of course, if you go to the United States and you take the same view of the indirect quotation, then it would be something like 0.94, I think. Let's see how much it is. Oops, there it is. No, this one not, but another one. Oh, I can use this one here. Because then, from the view of the United States, the indirect quotation would be just 1 over 1.07. So, okay, 0.93. But of course, you are not allowed just to subtract 0.07 because, of course, of the problem. If we, for example, would take here an exchange rate of 1.15, then we do not end up by 0.85, but here by 0.87. Yeah, and with this dependence, we derived after a longer calculation that we had done here the dependence or the result that the derivative, so we are coming from the above here, there we want just to calculate the sign of the derivative net exports with respect to exchange rate, and after a longer calculation we obtained this result down here. From this we know it is larger than 0, and this bracket here is only larger than 0 when the this has to be less than 0 because we want to have the negative dependence. This was wrong. This direction. This is only less than 0 if the sum of the absolute values of the exchange rate elasticities of exports and imports is larger than 1. Yeah, and this is a general assumption which is in the medium and longer run in time quite okay. This we find in practice, but I also added here these so-called J-curve effect, because in the short run we see that in the short run it is possible, if we have, so to speak, an exchange rate shock, that we have an overshoot in the reaction, that in the in the short run the dependence here could be the other way around, that for a while we have an increase if the exchange rate increases, but in indirect quotation. This also we have to keep in mind. If we use the direct quotation, then here we would have to have a plus sign. But this, of course, then would also mean that we change the prices, though the argumentation would be still the same. Okay, well, and now before we start with the whole model, I will discuss also, some paradoxon, because, well, in general, we would say it shouldn't matter if we use the direct or the indirect quotation. All the directions should be, or the argumentation should be in general the same. But in the 1970s, Jeremy Siegel, he found, or he was the first guy who described an effect that actually, if we take expectations, and this we are doing always when we are looking at the economy, because always we have some idea where will be the exchange rate tomorrow. And he was then the first guy who described that if we make expectations about the exchange rate, it matters if we take the expectation with respect to the direct quotation, or if we take it with respect to the indirect quotation. Well, and this is of course quite surprisingly, because why should it matter if I write down here the exchange rate in, so today it was 0.7, in 1.07 US dollars are equal to 1 euro, or 0.93457 euros, equaling 1 US dollar. Why should it matter? But yeah, let's do just a simple example, assuming that we have the indirect quotation for the euro, and yeah, let's assume that the exchange rate to have some higher values, that 1.15 US dollar equaling 1 euro. And now we have some expectations about the future, and we assume that with a probability of 25%, the exchange rate is falling, that the euro is depreciating, and be careful, the exchange rate in a number will increase if we take the direct quotation 1 over 1.15, but still this of course would mean that the euro then, even the number would increase, that still of course the euro would then depreciate. So, but we start with the indirect quotation because this is what we always see in the media. So with 25%, we are assuming that the US dollar, that we are depreciating to 1.05 US dollar per euro, and with 75%, we are assuming an appreciation up to 1.25 US dollar. Well, and now we are calculating the expected exchange rate tomorrow, and once we are doing it with the direct quotation and also with the indirect quotation. So E would be euro per US dollar, and oh, I forgot something. I'm just back in a minute. So back, this would mean that with 25%, we are depreciating, so 0.25 times 1.05 plus 0.75 times 1.25. Well, cannot do it in my head, so I just use this one, and So we have 0.25 times 1.05 plus 0.75 times 1.25. So we obtain an expected exchange rate of 1.2. Well, and now we are taking the expected exchange rate of the direct quotation quotation. Well, what we have to do now? With 0.25%, we are also depreciating, but we are just using the other way to describe it. So here we have times 1 over 1.05. Just doing it because we define now the exchange rate the other way around. Of course, this still means that we are depreciating. It's just the other description. Why should it matter? Let's see if it matters. 0.75 times 1 over 2.5. So within here, I take 1 over and 1 over. Oops. And we obtain 0.0381. Roughly 0.8381. Well, of course, that this number has to differ from this number is clear. But what should it be? In general, we would expect that it is just the number the other way around, that it is just the inverse. But well, of course, already we see the inverse of 1.2 cannot be a number which with many, many digits. And then to verify this, we write 1 over 1.2. And this is 0.8 period 3. So here 1.2 is 1 over 1.2 is 0.83 period, and this of course is different to 0.381. Well, of course, and this is puzzling. And why is it? And of course, if we go to the exchange to the currency markets, where we are trading very, very high volumes, then of course here a difference already in the third digit. Think of a large investment for taking a position of 300 million US dollars investing something. Then of course the third digit really matters. Well, and this still puzzles the people, because the question is, does it really matter? Because of course everybody knows this. And for this you really find many papers in the literature which are also try to estimate, does it really matter in practice, or doesn't it matter in practice? Well, but why is it the case? Why do we have this? And the explanation, of course, comes trivially from the statistics, and because we are dealing here with expected value. And the explanation I want just also to show you. Because, well, what do we have here? We have two stochastic variables. The one stochastic variable is E, and the other stochastic variable is 1 over E. Both descriptions of the exchange rate are stochastic variables or random variables. And what would be the case if we are calculating the expected value of a product E of E times 1 over E? This is just 1, of course, because E and E are canceling. And what is the expected value of a fixed number? A fixed number is, of course, not anymore a random variable, because it's fixed. If you remember, I think we have done it also in the revision. Some of you also are in the statistics course this semester, and expected value of a fixed parameter is just the parameter itself. So from this we know it's 1. But it is also, in general, if we say that E is X and 1 over E is Y, it is also the expected value of the product of two random variables. Well, and for the expected value of a product, we of course know that we also have to keep in mind, or we have also to take the covariance of these two variables. And how did we calculate? This is expected value of a product of two random variables, and then we have also to take the covariance of x and y. So the expected value of the product of two variables is not only the product of the expected values itself, because these two variables can be correlated. If the correlation of these two variables is zero, so if these two variables would be independent, then of course we have a covariance of zero, and then we would have only the product of the two expected values of the random variables itself. But of course, we have the exchange rate and we have 1 over the exchange rate. And of course, these two variables have to be correlated, because if the one goes up, the other one has to go down. So there is a definite dependence between these two variables. So the covariance cannot be zero. And if we calculate this, let's again remember what is the covariance of x and y. This would be the expected value of x minus the expected value times y minus the expected value of y. So this is just the definition. In order to remember this definition, remember what is the variance of a random variable. This is the squared distance from the expected value mu. And if you would put in for the y here in x, then you have just x minus e of x times x minus e of x. Well, and this is nothing else than x minus e of x squared. Okay, and if we this just multiply here, then we have x times y minus e of x times y minus x times e of y minus minus is plus e of x times e of y. And then remember, the expected value is an linear operator. So we know e of x plus y is e of x plus e of y. Then we can just split it. Only if we are multiplying these random variables, it is not possible. So this is e of x times y minus e of x times y minus e of x times e of y plus e of where we are e of x times e of y. Well, the expected value of a random variable is just again a fixed number. So this is then just E of x times E of y. Here we have a random variable x times E of y. E of y is, as an expected value, a fixed number, and we know linear operator E of a times x. If this is just a parameter, this we can keep out of the expectation operator. So this is a of E of x. Well, and if we could take this in front, then of course we have E of x, E of y times, and then we have only the E of x alone. So this is then E of y times E of x. Here we can do it in the same way. E of x is a fixed number. This we can take out. So we have minus E of x times E of y. And here still we have the product. And can I move this downwards? I think so. And then we see this and this is the same. And this is also the same. So this is 2 times E of x times E of y minus. And if we take then this minus 2 plus 1 equals then E of x times y minus E of x times E of y. Well, and then we see what we want to have, just this equation up here, because then we have the covariance of x and y is E of xy minus E of x, E of y, and moving this on the other side, we obtain then that the expected value of a product of two random variables is the product of the expected values of the two variables plus the covariance of x and y. And from this, we know this is just 1 because the e and the e are canceling. And then this would mean, oh, sorry, here we have to use an e. E. And then we have 1 minus covariance of E and E is the product of these two, where in general, when we are going back to our example, we would have expected that this is just the inverse of this, where we found no, it's not. And this, of course, has to be in general the case because these covariance has to be negative. Let's take this in red. Covariance of E1 over E has to be a negative number because we definitely know if E goes up, 1 over E has to go down, and the other way around. Because definitely E and 1 over E are negatively correlated. Well, here I have written it also down here. And for this, from statistics, this has to be the case that taking the expected value of the exchange rate has to differ if we take the indirect quotation or we take the direct quotation. Well, we are now dealing further on when we are looking at our models, not with the expected values. We just looking here at the exchange rate, but we have to keep this in mind that quantitatively we would have different results. And this, as I told you, is here 1972. This is a very famous paper. Jeremy Siegel is also a very well-known American economist in the United States, or not only in the United States. He is professor, I think, at the University of Pennsylvania, and he is also, I think, he is also running some investment firm or something like this, and in his investment strategies, he is also quite successful. So he is a multimillionaire. And well, if you look him up in the internet, I think you find also some pages with some blogs where he gives some hints for investment strategies and something like this. So if you are interested in finance, not only Warren Buffett, but only this guy and somebody else, you can have just a look at these guys. And I think it is then quite interesting that, sometimes you also find that these professors are sometimes quite successful and sometimes not. If we take, for example, maybe you have done this in other courses, when you are talked about derivatives and the so-called Black-Scholes formula that Norman Scholes, he runs or have run in the 1990s, a very famous investment force, one of the largest in the world, and they were betting on the interest rate on the interest rates of the members of the eurozone in before the euro was introduced. Well, and the bet was that the interest rates or the differential of the interest rates would narrow. So they really invested billions of US dollars, that especially the interest rate of Italy, which were very high before they introduced the euro, and they betted that they will be then in the ends of the 1990s, because we knew that we are introducing the euro in 1999, and so they betted in 97, 98 that the differential will very well narrow, but it hasn't narrowed that much. They have betted, so they lost around $1 trillion, and then they have to be saved by the Federal Reserve. So qualitatively, they were right. When you remember my macro course, I showed you that in the end, in the beginning of the 2000s, we had more or less there was no differential between the interest rate of the euro members anymore. But 2 years before, the decline was not that fast they have expected, and therefore they lost very, very much money. So this was, so to speak, a small financial crisis there. They had to be rescued by the American Central Bank, US Central Bank. Otherwise, we would have had also a problem already in 1998, 1999 in the financial markets in the world. Well, but I'm talking too much. So if you are interested, just have a look for him. Okay, but now we have discussed these dependence here of net exports depending on the exchange rate, and I gave you also this hint that we have to be careful when we are dealing with expected exchange rates. And yeah, then of course we have our LM curve. There nothing is changing. Still we have the positive dependence of home income, and we have the negative dependence, for example, opportunity costs of an investment on interest rates. And now we are looking at the balance of payments, and there we have the current account. Here we say this is roughly only the trade balance. We know there's also something else, but to be simple, we just use here the same exports minus imports. There we are knowing the dependence, and capital flows, of course, will depend on the interest rate differential. This is home interest rate, and this is interest rate abroad. Well, and if this would be positive, this number, then we would have a capital inflow, and if this number is negative, then we would have a capital outflow. Well, we also assume that we cannot do anything about these abroad interest rate. So this is, or we assume that I star is exogenously given. So for us, it is a fixed number. Well, in general, we assuming always that international prices and something like this are fixed when we are a small country. But I will show you, I don't know if I do it today. Where do I have it? Or then I can choose it just in front. Yeah, I move this a little bit up here. I will show you just in a minute a time series that it is still also a quite good assumption that also we from the Eurozone perspective, and we are, remember, one of the three largest economic regions in the world, but that it is still a quite good assumption that we cannot do anything about the American or the US interest rate, which is still the dominating interest rate in the world. Well, if we take this as a fixed number, then of course we also can say that the capital account is positively dependent on our own interest rate. If our own interest rate is increasing, then in general the capital account will increase. And of course, also this is depending on the expected exchange rate. Here, be careful, this again in indirect quotation. There we have, of course, always to use the same description. Well, and if we are assuming that our currency will appreciate, then of course our currency will be more attractive, and thus also we assume that we have a positive dependence of the capital account on the expected exchange rate. Well, and remember from the ISLM model, we gave the exposition in the diagram of interest rate and income. So LM curve here, interest rate and income, and here also for the IS curve, interest rate and income. And then we can ask, well, how, since we have here a dependence on interest rate, let's do it in another color, and here we have the dependence on Y, how would look like the dependence of these ZZ curves, so the curve derived by this equality sign that the balance of payment has always to be balanced. Therefore, we call it balance of payment. Well, and for this, in general, we could argue that if we have, so to speak, a good situation at home, that we have yeah, a quite good economic growth. So our home income increases. Then we assumed that we are starting to buy more goods. So this dependence here would lower our net exports, but we have the balance of payment. This would mean that the capital imports have to increase. So this lower implies, due to this equality sign in the balance of payment, if net exports go down, then on the other side, capital imports have to increase. But when we have an increase of capital imports, then we have to be more attractive for the international markets. And when we are more attractive for the international market, well, if the interest rate in our country is increasing. And this then would mean that in general, we will have also, like for the LM curve, a positive dependence from the balance of payment for the ZZ curve that does from the balance of payment, we will have a positive dependence between home interest rate I and home income Y. Well, and yeah, this I wanted to show you. Why is it a good assumption that we take this interest rate as fixed, even if we have a look from our country, from our continent, or in general from the Eurozone? Well, these are the time series of the interest rates of the ECB and the time series of the key interest rate of the Federal Reserve from the United States. Well, and what do we always see? We always see here, only with this exception, during the times between the financial crisis and Corona, but again, here more or less also due to our problems which we had in the Eurozone or in the EU. In general, also because of the Brexit and because of the problems in the south of Europe, we didn't start to increase during this time the interest rates, but now after Corona and when the inflation started to increase in 2021, then again always the Federal Reserve started to change the general interest rate policy. So when they start to change, to increase the interest rate, then more or less 6 or 12 months later, we also more or less have to increase the interest rates. So we are, during the last 25 years, only with this exception here, we are always more or less just following the interest rates of the United States. And for this, we then can say, although we are as large economically in an economic scale in Europe with a GDP of the EU or Eurozone almost as large as the United States, still the US are the economically dominating country in the world. And well, it is like it is. Still, we have to follow them. And also, you can say, no matter who is sitting in the White House, they will defend this position, that the US dollar will be the strongest currency or the anchor in the world. Okay, now it's already 9 point. We are already through with the time, so this I will do then on Thursday, and let's then put inside not, but this one I want to copy. Let's now have a look in general. ISLM model. So what do we have now is that we have interest rate, home income, and which colors I used? Red, blue and green. Okay. So then we have a red IS curve. We have the blue LM curve, and we have the green, and there we in general assume that this and this we will talk about in on Thursday. In general, we assume that the ZZ curve has also this positive dependence between interest rate and income, but that it is flatter than the LM curve. So this is the LM curve, and red the the IS curve. So here no, why is it not changing? No. This is too strange. This one. So in equilibrium, we have three equations, and this is IS. There we had the dependence of I, Y, and E. So these are the endogenous variables, LM, of I and Y, and ZZ of I, Y, and E, with three endogenous variables, and then all three lines have to cut in the same point. So what we then would have, if we write it down, we have y equals c of y plus I of I plus nx of what was it? I, not I, e and y, and we have, this is is, lm, we have m over p is L of I and Y, and we have that Z, that we have nx of E and Y equaling capital account of I and E of I. And this has to be solved simultaneously. Well, and especially we will look at the dependence via the ZZ curve in general on Thursday, how we can directly model these that Z curve. Well, and what we will also do is, in this case, we have flexible exchange rates, but we can also look at a scenario where we have fixed exchange rates. Well, for once, until 1973, we had in the world, in the system of Bretton Woods, fixed exchange rates, but still also we have in the world some countries which have fixed exchange rates. Some cases fixed exchange rate with respect to the euro, or in other cases or more cases we have fixed exchange rates, especially in South America of countries with respect to the US dollar. Well, and the maybe most famous example for fixed exchange rates is still the economy of China, because more or less they have still a fixed exchange rate, or they follow more or less from their monetary policy that they have more or less a fixed exchange rate to the US dollar. And we can also look at this model in a framework of fixed exchange rates. Well, if we have a fixed exchange rate, then of course E is not anymore an endogenous variable, but an exogenous variable. But what do we have to do then if we fix the exchange rate? Still, we have movements in goods and services. Or if we have a capital inflow, then we have a pressure on our exchange rate to appreciate. If we are prohibited to appreciate, then of course we have to intervene via the central bank, and the central bank has then to adjust the amount of money, and this would mean by the endogenous variables we have to exchange E with money M. And then we will do, we will discuss within this model also economic policy, that we look at fiscal policy and we look at monetary policy within this model, and what is then the impact of the adding of the ZZ curve to the effect of economic policy decisions. Okay, done. Thank you very much for today.